Hello, I'm Rachel. I'm going to talk about Space Shuttle Challenger disaster today. On January 28, 1986, Space Shuttle Challenger blew apart just 73 seconds after it launched, killing all seven crews, include Krista McAuliffe, who was chosen to be the first private citizen into space out of 11,000 other teachers. It was the first fatal accident involving an American spacecraft while in flight. The cause of the disaster was the failure of the primary and secondary O-ring in a joint in the right Space Shuttle solid rocket booster that provided the majority of the thrust to lift the Space Shuttle, the launch pad. What is O-ring? An O-ring is a ring of a synthetic rubber with a circular cross section that, when compressed in a groove, provides a seal. They are used in many different sealing applications, such as kitchen sinks, garden hoses, medical equipment, power plants, and solid rocket boosters. There are many types of rubber O-rings, and what are used for Space Challenger was Byton. Byton is a brand of fluoroelastomer originally developed by DuPont. It is commonly called fluorine rubber or fluor rubber. It's a relatively hard rubber that retains its characteristics in temperature from -20 Fahrenheit to 400 Fahrenheit. It features excellent resistance to chemicals, fire, weather, and oils. It retains its elasticity under full load, pressure, and heat, which is crucial for maintaining a reliable seal over time. Possesses a high tensile strength, contributing to its resistance to tearing and deformation. Due to these properties, Byton is used in high-stress, demanding environments like automotive fuel handling system, aerospace and military applications, chemical processing, oil and gas industries, and applications requiring excellent sealing against extreme temperatures and corrosive fluid. Its primary characteristic, why it was selected for this type of the application. It is very tough. These huge segments that weigh over 300,000 pounds each, that if they were not quite lined up properly, it may cut the O-ring during the assembly. And this material was the best to resist that. It was vital that the seal remain efficient for the whole of the flight. But temperature could change the behavior of this basing material. O-rings were used in the compressed state for solid rocket booster. They squeezed them into the joint grooves in a compressed state because the joint opened a little bit when it pressurized. Compression in the O-ring squeezed in there when it opened. It would maintain contact with the other surface as it was opened. The characteristic of doing that is called resiliency of a material. Temperature could change this behavior. When it is cold, it won't recover until it finally warms up. There were history of blow-by, means O-ring illusion by hot gases leaking and blowing by the joint. And for avoiding this risk, the recommended temperature was 53 Fahrenheit and above. This shows the shuttle parts. Each solid rocket booster was shipped in 4 pieces and had 3 joints, 6 O-rings. Rocket boosters are assembled on the mobile launch platform by stacking. There is a joint that is made to assemble the entire rocket booster. In that point, it has to be made sure that the gases cannot escape. That is what O-ring does in here. Florida, the morning of January 28, 1986. It was an unusual cold day. At a temperature that was just 38 Fahrenheit, and the shuttle's temperature was 28 Fahrenheit, much colder than air. This made it the coldest launch in NASA's history. Because of the colder temperature, the O-ring material was less malleable. When compressed and released, the O-ring material moved slower, which allowed hot gases to flow through the gap. Hot gases blow past the compressed O-ring seals, igniting and ultimately burning through the external fuel tank. Space Shuttle Challenger exploded after 73 seconds it launched. Actually, there was a bigger reason caused this disaster. Engineers and Moltenklo, the company that built the solid rocket boosters, had warned managers the night before the launch that O-rings were not safe below 53 Fahrenheit. Their recommendation to delay the launch overruled by managers under pressure to maintain the flight schedule. The failure to stop the Challenger launch has become a case study for the dangers of groupthink, desensitization to risk, and the danger of putting cost-cutting and schedule deadlines over safety. They designed solid rocket booster joint and then STS-26 Space Shuttle Discoverer successfully launched on September 29, 1988 after 32 months Challenger disaster happened.